Here we're told the length of a hypotenuse and one of the legs in a right triangle, and we're asked to use that to find the length of the other leg. So our first step is to make a sketch of a right triangle and label our sides. The legs are the two sides that form that right angle. So if you look over here in the top right, we see these are our legs because they form this right angle. So in our case, this would be a leg and this would be a leg. So it's telling us that the length of one of its legs is 8. So let's say this one is 8. The hypotenuse is always the longest side. It's the side that is across from our right angle. So in our case, this would be our hypotenuse, and our hypotenuse is 12. Now, if you have a right triangle and you know two of the side lengths and you don't know the third, you can always use the Pythagorean theorem, which is right here, to find the length of that missing side. So we need to know what is A, B, and C. Well, C is always going to be our hypotenuse. And then our legs are A and B. It doesn't matter which one you pick to be A and which one you pick to be B. Once you know A, B, and C, you can substitute them into the formula. And now we're going to solve for A. Now it's good practice with equations before you start moving things around to simplify a bit. So first off, 8 squared. 8 squared is the same as 8 times 8, which is 64. And 12 squared is 12 times 12, which is 144. So this is our new equation. Now let's move, we want to get what is squared isolated. So we need to move this plus 64 over to the right side. And we do that by doing the opposite of adding, which is to subtract. So we end up with a squared equals 80. Now that what is squared is isolated by itself, we can undo that squaring. And we do that by taking the opposite, the inverse of squaring, which is the square root. So let's take the square root of both sides, and what that does on the left side is it cancels out the square, so we're left with A. Now, if you put the square root of 80 in your calculator, you're going to get a decimal that you're going to have to round. If you want to present your answer as a more exact answer where you're not rounding, you need to see if you can simplify the square root of 80 a bit. See if you can take the square root of any part of 80. Now to do this, you want to come up with the factors, the numbers that multiply to be 80, to see if there's anything that's being multiplied by itself. So what I like to do is make a factor tree, and you're going to do prime factorization, or that's how I'm going to do it. Sometimes people can come up with bigger numbers. I just like to break it down into all of those prime numbers that multiply to give me 80. So first, I know that this is even, so I know I can divide it by 2. And 80 is the same as 2 times 40. Now 2 is a prime number. I can't break it down further, so I like to circle that. 40 though, I can break down. That's the same as 2 times 20. 20 is the same as 2 times 10. And 10 is the same as 2 times 5. So, the square root of 80 is the same as these factors, 2 times 2 times 2 times 2 times 5. Now that I've broken it down into numbers that multiply to give me 80, I can take a closer look and see if anything is being squared. Well, what's being squared? 2's being squared. So I can pull that out from underneath the square root symbol. Anything else being squared? Yep, another 2 is being squared. So I can also pull that one out. But nothing else is being squared, so I need to leave that 5 underneath the square root symbol. So when you simplify this, outside of the square root symbol is 2 times 2, which is 4. Inside the square root symbol is a 5.